In this video, we'll be going over Gauss-Jordan elimination. So a linear system could have three of the outcomes, which are that the system is inconsistent, meaning that there is one solution, exactly one solution, and infinitely many solutions. So in this video, we'll be going over an example of exactly one solution here. So here we have three unknowns, which are x1, x2, and x3, and we need to find the values of that. So the first step that we have to do is write this systems into the augmented matrix format, which is just writing the coefficients on the left hand side of the x1, x2, and x3, and the number on the right hand side. So let me just show you what that looks like. So as you can see, the first column is x1, second column is x2 and x3, and these are just the coefficients. So in the first equation we can see that the coefficient of x1 is 1, coefficient of x2 is -2, and x3 is 3. So we just basically write that, and then we draw a vertical line and after that, and then equal to whatever that is, so 5, 1, and 24. And now what we have to do is we need to convert this into the reduced row echelon form, which basically means that we have the pivots, which are, let me highlight them, these numbers as 1, and whatever is above them or below them has to be 0. So these highlighted in the red has to be 0. So I had made a video on RREF, reduced row echelon form. So I'll just be showing the operations done here very simply. So let's do that now. So the first step, that let's get rid of this 5 below this 1. So we don't need to change this 1 into anything since it's already a pivot and it's 1. So let's do the operation of minus 5 R1 plus R3. Don't mind my handwriting here. And this will give us the matrix of this now. And now we notice that the second pivot is 2, and there is a 2 below it also. So one thing we can do here is we can use this pivot to get rid of this 2 here, and this -2 also, since we cannot have any number above the pivots also. So we will do the following operations, which are R1 plus R2, and we will do minus minus R2 plus R3, and this will give us, so this is the result now after the operations. And we notice that now we have only 2 here, and we have a -3 above this pivot. So first of all, what we can do is convert these pivots into ones, and then use this 1 here to get rid of this -3. Or a simpler method would be to convert this 2 into 1 and then use this to get rid of this -3. So I think, yeah, leaving the pivots to reduce it, to divide it into 1 is the best thing, is to leave it at the end. So now let's divide the row 3 by half. So it will be half row 3, and then the matrix will be this now. And now we can use row 3 to get rid of this -3, which will be 3R3 plus R2, and this will give us the following matrix as this. And now the last step is to divide the second row by half to get this 2 into 1. So let's do that now. So 1 over 2 R2, and this, the final matrix will be as shown below. And we can highlight the pivots now into yellow. So this is the first pivot, this is the second pivot, and this is the third pivot. And now we can write it into the equations format again. So x1 is equal to 6, x2 is equal to -1 and x3 is equal to -1. Now there is a shortcut on the calculator where you can just type your equations from the first step, which is this, and it will give you the exact answer directly on the calculator. So this is really helpful if you want to recheck your answer, or if it's in a MCQ question format where you just need the final answer. So I'll be making a YouTube short on that shortly, and I'll see you in the next video then.